Right, today we're going to talk about solving quadratics using the quadratic formula and the discriminant, which is another method to go ahead and solve quadratics. We've talked about solving by graphing, solving by factoring, solving by completing the square. The quadratic formula is a really nice method to go ahead and solve quadratics. So let's go ahead and let's talk about what the quadratic formula actually is. And the definition of the quadratic formula is let a, b, and c be real numbers such that a does not equal 0. The solution to a quadratic, ax squared plus bx plus c equals 0, those solutions are going to be x equals the opposite of b plus or minus the radical of, and underneath the radical you got b squared minus 4ac, and then the whole thing right here is divided by 2a. Okay? This part underneath the radical over here, this is known as your discriminant. All right, and we will go ahead and we will talk about what the discriminant is at the bottom of this note sheet. Okay? So really, when we're looking at this, the important things to be able to do are to identify your A, your B, and your C when we're talking about quadratic equations. All right? So for the first one right here, what we need is we need this thing to be in standard form. All right, so I'm going to take this 6x, I'm going to move it this way. I'm going to take this minus 4, I'm going to move it this way. And I'm going to put this quadratic into standard form of x squared minus 6x plus 4 is equal to 0. Okay? In the past, what we did is we took this 4 and we factored it, and we tried to go ahead and get this b term in the middle. But for this example, when we factor it, it's not going to work. So we're going to go ahead and we're going to identify what my a term is, my b term is, and my c term, all right, so that we can go ahead and solve it using the quadratic formula, okay? So my number here in front of the x squared is 1. My number in front of the x term is negative 6. And then my c value right here is going to be a positive 4. All right? So I'm going to write and start to solve this as x is equal to the opposite of b, because that's what I have, opposite of b. So I have 6 plus or minus the square root of b squared, which is negative 6, minus 4 times a, and my a is 1, all right, times c, and my c is 4, all under square root, divided by 2 times a, which is 1. Okay? I'm going to go ahead, I'm going to solve underneath my square root first. I'm going to determine what this discriminant is. So I get 6 plus or minus the square root of, this is 36. And then I got negative 4 times 1 times 4 gives me negative 16. All right? All over 2 times a, which gives me 2. All right, so now we get x is equal to 6 plus or minus the radical of 20 all over 2. And that, when we simplify radical 20, it comes out to be x equals 6 plus or minus, 4 is a perfect square in there, so I'm going to go with 2 radical 5 over 2. All right, now we go ahead and we take a look at my divided by 2, and I'm going to simplify here. I'm going to end up with x is equal to 3, all right, plus or minus radical 5. So there are my two solutions to this quadratic using the quadratic formula. Okay, so we noticed in this one we ended up with two solutions, and we'll talk about that in a minute. All right, in my next example here, all right, I'm going to go ahead, I'm going to turn this one into standard form. So I got 4x squared, I got minus 12x, I got plus 9 is equal to 0, where my a term is equal to 4, my b term is equal to negative 12, and my c term is equal to 9. All right, x equals opposite of b, so I got 12 plus or minus the square root of negative 12 squared minus 4 times a, which is 4, and then I got times 9 right here, all over 2 times 4. X equals 12. We're going to go ahead and determine what the discriminant is. All right, this part right here gives me 144, and then this part right here gives me minus 144. So I really end up with 144 minus 144, which is going to give me 0. All right, so I have to get rid of that right there. So I got 12 plus or minus the square root of 0 divided by 8. All right, we know the square root of 0 is 0, so I have 12 plus 0, which would give me 12. I got 12 minus 0, which would give me 12. So I end up with x is equal to 12 over 8, all right, which simplifies to be 3 over 2. So my x value for this one, I only get one solution of 3 over 2. All right? This one we got two solutions. This one we got one solution. Let's go ahead and let's take a look here at what's going on with my next one. This one is in standard form. A is equal to 1, B is equal to negative 8, C is equal to 17. X equals 8 plus or minus the square root of negative 8 squared minus 4 times 1 times 17. All right, all divided by 2 times 1. We end up with x is equal to 8 plus or minus square root of 64 minus 68 all over 2. X is equal to 8 plus or minus the square root of negative 4 over 2. And now what happens here is this discriminant is a negative number. So we know that this simplified becomes, we take out the imaginary unit, and then we take the square root of a positive 4, so I end up with 2i here. Okay, so this one becomes x is equal to 8 plus or minus 2i all over 2, and that simplifies to be 4 plus or minus I. So I end up with a solution of x equals 4 plus or minus I, which is two imaginary solutions. Okay, so I want to pay close attention to what the discriminant was here, what the discriminant was here, and what the discriminant was here, and its relationship to the number of answers that we get, the number of solutions. Okay, so if your discriminant comes out to be a positive number, so this part, if b squared minus 4ac is greater than 0, what we get is we get two real solutions. Okay? And we know that with two real solutions, what my graph would look like is it's going to be a parabola that goes ahead and crosses my x-axis, right, and creates two intercepts. That's two real solutions right there. All right? The second one, if my discriminant is b squared minus 4ac is equal to 0, look at how many solutions I ended up with here. I end up with one real solution. And we know that that graph, all right, goes ahead and touches my the parabola touches my x-axis at exactly 1 point. And we know that that point is going to be my vertex. All right, so this graph, you have your vertex that touches your x-axis and creates one real solution. Okay? The last thing we have here for my discriminant is that b squared minus 4ac is going to be less than 0. And we know that this one, as we see, we get a negative number here. We came up with two imaginary solutions. Imaginary. All right, two imaginary solutions. And we know that this graph, all right, is going to look like, yes, you're going to have a parabola, all right, that does not intersect your x-axis anywhere. So what we have in this one is you end up with two imaginary solutions. All right, this, guys, is solving quadratics by quadratic formula. You can use this to go ahead and solve any quadratic. However, a lot of times other methods are more appropriate, factoring, graphing, solving by square roots. But this is a great way to go ahead and solve any quadratic if you ever get into a bind. Okay?